Okay, guys, today I'm going to solve this classic problem using the Pythagorean theorem. I have here a triangle, side length 5, side length 6, and this here is side length 9, all the way across the base. I have a perpendicular h drop down, length I don't know, which divides my triangle into two right triangles. And the problem that I have is that I'm being asked to solve is to solve for this height here, h. So how do I do this? Well, I started, as you can see, by labeling this distance here y. That is this distance here. Therefore, as this entire distance is 9, this distance from here to here will be 9 minus y. So I have 9 here, this is y, so this distance is 9 minus y. And my strategy to solve this problem is to use the Pythagorean theorem to set up two equations and then solve those equations if I can. Okay, so I'm going to start with this triangle right here. I have a right triangle, side length y, side length h, and my hypotenuse here, the long side, is 5. The Pythagorean theorem tells me that in that case, h squared plus y squared is equal to 5 squared. That is that h squared plus y squared is equal to 25. And that gives me what I'm going to call equation number 1. H squared plus y squared is equal to 25. Okay. Looking at my second right triangle right here, I see that I can use the Pythagorean theorem again. That would give me over here h squared plus, this side length is 9 minus y. So that is plus 9 minus y squared is equal to, side length is 6, that is 6 squared. Multiplying this out, I have h squared plus 9 minus y squared. 9 minus y squared that's 9 squared, that's 81. Multiplying these two together, that's 9 times negative y, that's minus 9y, double it, that's minus 18y. And then I square the final term, that's minus y squared, that's plus y squared, is equal to 6 squared is 36. And so I have a second equation. Equation 1, equation 2. You'll notice that h is common to both equations. That's, of course, because this side here, h, is common to both triangles. You might be tempted at this point to maybe group these terms together, or maybe find like terms and bring them together and simplify this equation. I would hold off on that for just a moment, and I would see that because I have here an h squared and I have here an h squared, I could substitute in a value for h squared from one equation into the other. That is to say, in this instance, from equation 1 into equation 2. If I rearrange equation 1 using a little algebra, hopefully you can see that I get h squared is equal to, subtracting y squared from both sides, I get 25 minus y squared. Okay, h squared is 25 minus y squared. Here I have h squared. So I'm going to substitute in this value of h squared in here into number 2. So I'm going to sub this in here into my h squared. My second equation then, equation number 2 will become, substituting in, instead of h squared, I'm going to have 25 minus y squared. It's this value here, substituting that in for h squared, plus 81 minus 18y plus y squared is equal to 36. Okay. Now at this point, I'm going to group any like terms together that I can. Well, straight away, I see that I have some terms that will cancel. What's very nice about this is that my y squared, my negative y squared, and my plus y squared will cancel with each other right there and there. Those two will go away. And so I can rearrange. I'm going to bring over my 36 because I have 25 and 81. I'm going to bring my 36 over to this side and become negative 36. And I'm going to bring my negative 18y over to the other side of my equation, to the right side. It's going to become positive 18y. And so this will become, I have 25. I have that plus 81. My 36 can come over and become negative 36 is equal to my 18y. When that comes over, that becomes positive 18y. 25 plus 81 minus 36. For that, I think I'll just use my calculator. Simplest way to do it. 25 plus 81 minus 36. That gives me 70. It gives me 70 for that value. So I have 70 is equal to 18y. That gives me a value of y, therefore, of 70 divided by 18. Y is 70 divided by 18. Okay, so I have worked out this value. That is this value here. I could go one step further, simplify this. 70 over 18 is the same as 35 divided by 9, dividing above and below by 2. And so I now know my value here for y. It is 35 over 9. That is approximately 3.8, 3.9 from here to here. The question, of course, asks me to calculate this value h. But if I look at my equation 1, we see that I have h squared in terms of y squared. So in other words, I have h in terms of y. So I can calculate h squared now that I know y. Because I have a value for y, I can calculate y squared. If y is 35 over 9, it follows that y squared is equal to 35 over 9 squared It's a rather awkward looking number. It's 1225 over 81. Say it's rather awkward, but I don't care about that. And you want the value. The calculator will take care of the big digits for me. 1225 over 81. I can now substitute this value in here into equation 1. That gives me that h squared is equal to 25 minus 1225 over 81. And therefore, h squared is equal to, again, going to my calculator, 25 minus that answer gives me a value of h squared of 800 all over 81. That's what I get. That's fine. Now that I have h squared, I can calculate h. H, therefore, is clearly the square root of 800 over 81, which my calculator tells me, taking the square root, is 20 root 2 over 9. Again, it's a rather awkward looking number, but that's fine. 20 root 2 over 9 is the answer. And so I can tell you, my calculator can tell you that that gives me a value of h that is approximately 3.14. I only check to see what this is because I want to make sure that my answer makes sense. I see here that I have a side length of 5, 6, so a height of 3.14 just about makes sense. That makes sense. I'm getting an answer that I would expect. But this here, value of 20 root 2 over 9, I leave my answer in that form. And I think you can see that that is correct. And so I'm happy with that answer. So that's how we go about solving this kind of a problem. You can see it's simply using the Pythagorean theorem. I use it on this triangle. I use it on this triangle right here. I substitute my value of 8 squared, which is common to both, from my equation 1 into my equation 2. And that allows me to solve for y, which then allows me to solve for h. Okay, I hope you found this helpful. And you'll try some problems like this yourself.